G'day viewers, this is Troy from Troy's Visual Arts channel. In my previous video I had the camera switched on and the bridge rectifier was smoking up and burning up on me. Well, after a bit of mucking around and testing and that sort of thing, I've worked out the problem is not at all to do with the main power board, but in the power supply, but to do with the power supply and the AC power supply itself. Basically, firstly, what's been happening is because I had the earth connected to the center tap of the transformer. When I was putting 20 volts out into the circuit, and the negative end of the rectifier was connected to earth, and the earth was connected, and the earth is connected to the chassis here. I was only getting 10 volts going into the rectifier for starters, so I was only getting about 14 volts out. That was one problem I was getting. So I also figured that might have been the reason why the rectifier was drawing so much current, and yeah, I wasn't 100% certain, but I decided to put a toggle switch to switch the earth point from center tap to the right hand side there, so I can get 20 volts out and have one side tied to earth. So the center tap earth is off, but the right side is on. So I did that, and it works. I can switch to the right. I can switch the earth to the right side, or switch it to the center, whatever I decide to choose. So that fixed one problem, and I was getting 29 volts out. Oh, by the way, it took me a few rectifiers to figure this out. So I smoked a few rectifiers in the process. Even when I unplugged this circuit, the rectifier was still smoking up. So then, yeah, I turned my attention to the AC power supply and that power supply. Well, anyway, yeah, so I fixed that problem, but the rectifier was still smoking up on me. So somehow it's drawing a lot of current because of the fact that the negative end of the rectifier is tied to ground, and the ground is of course tied. The ground of this is tied to the ground of that. Well, anyway, what I then figured out, okay, let's current limit the amount of current going to the rectifier to begin with. So yeah, I've got a 220 ohm resistor connected to the rectifier, and sure enough, that fixed my smoking up problem. So I switch her on, and the voltage will build up to around 30 volts. And yeah, the rectifier is not smoking now. The rectifier ain't even hot. I left it on for a few minutes and it didn't even heat up. So that solved that issue. But I'm still kind of wondering why the heck is it drawing a lot of current. So that's kind of got me a bit baffled. But this is the solution to the overdrawing of current issue to the rectifier. So yeah, stick a current limiting resistor in, and that solves that problem. Now, it doesn't exactly need to be 220 ohm. It can be something. I reckon it can be something a lot less. Perhaps maybe put a 47 ohm in or something like that. Just I just want just enough current to supply the necessary current to the main power board, but not too much current that's gonna heat up the bloody rectifier so much. So yeah, that will be the next plan of attack. And then yeah, that solves that issue. The other voltages on the main board are actually fine. I've I've tested them out and they're pretty much their respective voltages. I'll just switch the power supply off just for now, and I'm just going to pause the video and get the leads onto the chassis and onto the high voltage points. So okay, so I've now got one lead connected to the ground lead connected to the chassis. I'm going to power up the AC supply and I'll show you the voltage outputs. Now the first output is going to pin 5, which should be about minus 68 volts. So put the lead on there and you get minus 68.1 volts. The next output here goes to pin 2, which is an extremely high voltage of 420 volts. So put down there, we got 422 volts. And the next one's pin 6, which should be about 300 volts. And we go to pin 6 now, and it's 303 volts. And pin 7 is supposed to be around between 125 and 228 volts, and we're getting 183 volts. So it all depends on where I've got the focus trim pot adjusted to. And yeah, we've got the lead that goes to the ALC, and just to find about whereabouts on there it is. So there's an output that goes to the ALC, and yeah. But anyway, we're getting a voltage. We're getting a sort of like a considerable voltage on that. If I can get the lead, yeah. So we're getting about 78 volts on the ALC output. No, wait, that's the target volts. Sorry, no, it's target volts. Yeah, I've written the wrong thing down. Well, anyway, no, wait. I'm actually, yeah, probably is a target volt. Probably, actually, I really don't know what that connection is. I think it's target. Well, anyway, the voltages are pretty much spot on, so that's good in that section. So that section of the power supply is working, no worries. And yeah, well, anyway, just got to now work out a suitable resistor, current limiting resistor for the 20 volts AC, and we should be right as rain. And then yeah, then we'll connect it all up and yeah, see if the rest of the circuitry actually works or not. Well, anyway, that's it for this update, and yeah, I'm glad I finally found the problem, and yeah, stay tuned for the next video. Hope you enjoyed this video. This is Troy from Troy's Visual Arts channel signing out.